Look at the book, let's have a look here. Thank you. Now, last time we were looking at how to find the partial fractions and to simplify the improper into proper. So now what we're going to look at is why bother doing that. So let's have a look at some examples. Let's do something like 1c as an example. So I ask you to integrate minus 6x plus 22 over x squared minus 10x plus 25 dx. Yeah? Now, what methods do we remember that we had for problems like this? We could complete the square in the denominator. Good. And what else is there?
U equals square root.
The first over the second. Good. And what other methods do we have? There's something else we could have tried here. Maybe let u equal to this. Yeah. Now, all those methods will fail to get an answer. They'll all fail. So the new method we have for today is by using the partial fractions. And you might say, in the exam, how will I know which method to use? Because in the exam, part one of the question will be to write this in a simplified form. A over x minus 5. Now look what happens here. This will be x minus 5. So the second one will be x minus 5 squared. Now we have a choice on the top. We can go with bx or we could just go with b. Yeah. In fact, we should think very carefully about which one we want to use, because remember, in a moment we'll have to integrate. So actually we want to think very carefully which one to use. Which one should we use?
B.
Yeah, the B will make it a little bit easier. So I get minus 6x plus 22. A x minus 5 plus b. Yeah, because I multiply by x minus 5, x minus 5. Yeah? So they cancel that. One of them cancels one of them, and both of these cancel that. Okay, so let x equal 5. That's minus 30 plus 22 is minus 8. So b equals minus 8. And then x equals 0. So that's 22 22 plus 8 is 30 divided by minus 5 is minus 6. Right, so let's go back to the question. This can now equal minus 6 over x minus 5 plus minus 8 over x minus 5 squared. Yeah? Okay. Integrate. This first one is not so difficult to integrate. You did this in semester 1. Does anyone remember the answer for this first one? Does anyone remember? Minus 6, we'll take that out. And what about 1 over x minus 5? What does that integrate to? Very good, yeah. And then what?
X minus 5.
Good. Now, the second one though, how can we integrate this guy? Any ideas? For this one? Right?
Multiply.
Not multiply, it doesn't actually help. No. Not this either. Nice try though. Any other ideas? No ideas?
I'll use A.
Use A.
A equals. You.
Yeah?
Equals x minus 5.
Very good.
That's what I mean. A equals x minus 5.
Okay. A though? Why use the letter A?
Well, we always use A.
Where do you always use A? A or U?
A.
A?
It's same.
I know it's the same, but it's strange. Alright, du dx? 1. So du equals dx. 1 dx, yeah. So that's nice because that changes this into this. 1 over u squared is u minus 2 du. Well, that's easily integrated now. What does that become? Minus 8u minus 1 over minus 1. So last step, minus 6 log x minus 5 plus 8 over u plus c. Yeah.
Then you can zoom out.
This much.
I need the top one.
Can you see? No.
I need glasses.
Yeah, where are your glasses?
No.
The Jerry
no,
trick.
No, I mean I have like eye issues that I find glasses not satisfying.
That?
No.
That's fine.
Too bright. Too bright?
No, I mean.
Okay. Let's see about a hard one. In a moment, will do, as another example, I. So, if you want, you can get a start on it. Once people are ready, I'm going to do I. Have a look at it. No, I. You're on page 36.
Yeah, minus 47.
Where's minus 47? I.
Ah.
It's L.
Oh. Jerry.
So we do I.
Well, just no. Well, I can do it now if everyone's ready, but I think someone's still writing. So, I mean, the first thing you can do for me to help me out is get the roots of that cubic. Okay. Yeah? Can start it? Okay. Lee?
Yep.
Can start it, yeah? Right. Now, did you get the roots?
Yeah.
Yeah? And what did we get for the 3 roots? Or are there 3 roots? 3x plus 1. Is there only 1 root?
Yeah.
Very interesting. What now?
One and the other is
Imaginary, yeah, so there's only 1 real root. So, It could be that.
Also we have to use
Or-
long division.
Yeah, very good. Because it's possible that the other factor is a quadratic that doesn't have any roots. Now I know why it's not true. How can I know it's not this or this? Because this finishes in a 1. If I square and cube this, I could never make 45. So it must be that this is a quadratic here. Isn't that what it is on the top?
8.
Oh, sorry, I'm looking at the wrong thing. Well, no matter, I could never make an 8. I could never make an 8. So, you have the idea correct, Andrew. How can I get that missing quadratic?
Long division.
Yeah, 3x plus 1 divided into 3x cubed, yeah? Oh. Okay, so firstly I need an x squared, I think. Plus x squared here. Oh, I need a minus here, don't I? And I need a minus here. No, too late now. Yeah, no, I know it would have been, but too late now. Minus x squared times that, and that. Subtracting is that. So what's next? Minus 4x, isn't it? Eight, and that will cancel it. So this is the quadratic that I need. Minus x squared minus 4x minus 8. So going back to the question now. Minus x squared minus 4x minus 8 was what I got from this one. Okay, so let's think about what the 3 factors could be here. Right, what would be the first one? 3x plus 1. And the second one? The quadratic. Now, what do I have on the top here? A. Yeah. Bx plus 2. Yeah? Okay, so I get 6x squared plus 15x plus 45 equals, now if I multiply by these two, I'm left with a minus x squared minus 4x minus 8 plus bx plus c times 3x plus 1. So what should I choose for my first x? Set x equal to what? Minus 1 over 3, huh? Good. What about for my next one? Oh, and this gives a. Right, what should I do next for x? 0. The 0 cancels this. We already know a, so what can I get from that? Gives me c, because this and this I know. And lastly, how to get b? How can I get the b? Yep. In fact, it doesn't really matter, but x equals 1 will do just fine, because we know x, a, and c, so we can get the b. So what I want everybody to do now for me is to get me the a, c, and b. And I tell you the steps here. Okay, so go get the a, c, and b now.
Stephen, isn't expanding that equation much easier than substituting x?
You could expand it and make a simultaneous system. But this is the reason I showed you the two methods, because it's whatever you prefer, your preference. Something deep inside my heart tells me that would be harder for this example.
That one, for this example. I think expanding one is much easier than this one.
Always, or for just this question?
Always.
Always?
Yeah, I tried all of the questions yesterday, and I tried both methods, and expanding one is much easier for me.
For you? Okay. Well, that's fine. In the exam, you can do both. I mean, well, not both, but either. There was never a problem?
Problem you gave me,
What I mean is, like, the expanded never caused a problem?
no.
No. Understand.
Zero, how much can I use my calculator? Like, I just...
You can use it as much as you want. It's just what you write down in the exam.
So I just need to show them the process and actual calculation I just need.
Yeah. Like, we'll have a look at the marking scheme. You can see how the marks work. You have two types of marks. You get a mark for the right process, and then you get a mark for the right calculation. And sometimes the question says, you must see all the steps. But usually it will say that in the question, like, integrate this and show all your steps, because you know on the calculator you can integrate it.
Teacher, I think
What?
that I feel zero because I A.
No, because you still have C.
I mean, we first get A, I first get B and C.
If you put x equals 0 first,
Yeah.
but if you put x equals 0 first, you'll have an A and a C.
But if we put minus 3, we have A. No.
You only have A. No, this is gone. This is 0.
But
This is 0
why is that really 0?
because of this.
Minus B.
No, forget about this. Just look at this. If that becomes 0, then
1 over 3, not B.
I equal 1.
yeah or no?
It's not minus 13.
Monica, do you have the A?
Minus 6.
You have the A? Thank you. What's the A minus 6? And you have the C?
No.
Okay. Minus 3, thank you. And does anyone have the B yet?
Wait.
Okay.
Teacher.
What? Do you have it?
You see, everybody still wants expanding. Much easier. We have something.
Personal preference.
3. Right?
I trust you, mostly. Right, let's have a look at the answer here. So we want to integrate minus 6 over 3x plus 1. Yeah. Plus 3x minus 3 over minus x squared minus 4x minus 8 dx. This one, easy. This one, hard. Let's see what we can do. This one is just going to be minus 6 over 3 log 3x plus 1. Hey. What should I do about this guy? What could I do?
Yeah.
Huh?
Substitution.
Yeah. You could say u equals the bottom,
Yeah.
and that will not work.
Then one more.
Completing the square? Almost.
Equals.
Well, first things first. Let's take out the minus and the 3. Okay, let's do that first. So that would be x minus 1 over x squared plus 4x plus 8. Okay? Now, what to do next? Complete the square.
X plus.
No minus. I only took the minus out of the bottom. The trick here, watch this now, we can make it two problems. That's the first one, and then the second one is this. Can you see what I did? I took this and put the x here and the minus 1 here.
What minus 1 changes to 1?
Well, the minus here.
Oh.
Yeah.
Yeah.
So do we have to put that big bracket?
No, because I put the minus in and changed it to a plus. Now you might say, why do that? Well, because now I've made two easier problems. This one here, watch this magic. Minus 3 over 2 integrate 2x Something went wrong.
That's not zero.
So what's the rule for tan inverse? Integrate x squared, 1 over x squared plus 1, is it?
Yeah.
Yeah, okay. Now this one's fine. This one could be fine. Actually, this one could be harder than I think. Let me ignore the middle one for a moment. Actually, this one could be okay. And then here, this will be 3, 1 over x plus 2 squared plus 4 dx. Okay, so how do we deal with this guy? Yeah, u equals square root this over this, which will be x plus 2 over 2. What is du dx? 1 over 2. Do you remember this one? We make u equal to the root of this over the root of this. So now, blah 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 plus 3 integrate 1 over 4u squared plus 4 2 du. That's what you get here. I can cancel, and now I have dot 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 3 over 2 1 over u squared plus 1 du, which equals dot 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 plus 3 over 2 tan inverse u. So I have this and I have this, but I still need to get this.
Hold on,
Yeah.
where is that tangent?
Where's what?
Why is there a tangent?
Why is there tangent? Oh, because this one
Yeah, it's tangent.
is tan inverse. Remember?
Yeah.
Continue. So look, I have this left. Minus 2 log 3x plus 1 plus 3 over 2 tan inverse x plus 2 over 2 minus 3 integrate x over, what's 0?
B is 0.
Oh, thank goodness, that's great.
Yeah.
That's wonderful.
No, second.
That makes me so happy. Because if the b is 0, that means that's a 0. Which means all the way down here, this part here was a 0. Because I was worried, I don't know how to integrate that.
No way to integrate that.
Yeah, because that's the answer.
The minus
Yeah, because the b...
makes everything
Huh?
big.
No way.
Oh no, I didn't say. No, just because I can't do it doesn't mean it's impossible. I'm just saying, you could see I wasn't sure how to integrate this. That's because it's too difficult.
So there is way. But you don't know.
You see, you're tempting me to try to integrate it. And you know what? I'll try.
No.
Just to see what happens. Guys, so you know the b should have been 0, which is good news. It makes it easier. Again! Well, you can't have both. Do you mean to scroll up or something?
Yeah, maybe.
But you already have the ABC.
Yeah, and after it.
After ABC? It's just me saying the problem. You want to integrate the A over the first one plus the BX plus C over the second one.
Yeah.
Well, that's too small.
But when this uploads to YouTube, it's going to be a high def, widescreen video. Scroll up. Six over 3 here. Yeah, because the integration of I just took the 6 out, so you're happy with that. And when you integrate 1 over ax plus b, the answer is 1 over a log ax plus b. Do you remember this rule? From semester 1? That's 1 over a log ax plus b.
But you have taken the 3 off.
Huh? No, I didn't. That 3 is coming out because of the rule. I only took the 6 out.
Oh.
Yeah, it's like 6 here. Look, Lee, 6 here, and now the 6 is here. Just scroll down a little bit.
So why is x minus 1?
Where?
The first line.
Why is x minus 1?
Yeah, because it's minus 3 and you have taken minus 3 out.
Yeah.
So it should be plus 1.
No, Sean asked me that already.
Oh, sorry.
Sean!
I was solving B.
I know, and I do appreciate that. He's asked me what you asked me. Why is this a minus and not a plus?
Yeah.
Yeah, tell him why.
Because you don't know either.
No, he does know.
Oh, I see. Because the minus at the.
I only took
the bottom is also minus.
Yeah, I only took the minus out from the bottom.
So it's supposed to be 3.
What's supposed to be 3?
But minus 3 over minus x squared minus 4x minus 8.
What? What are you saying?
What is this?
Can I continue? No. Go down. Oh. What?
B equals 0.
I know that. I know. We fixed it. That should be 0. That should be 0.
No, I don't have to.
Yeah, she doesn't do that.
Yeah, that's what I said, so I don't have to do this. That's what Lee said 5 minutes ago.
There was no one.
You can't follow the lead.
That's the rate.
Hmm? Yeah, sorry, that's a 4u squared plus 4 is what this piece is here. I just wrote the dot 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 here because of the other pieces. I just have to work it out. Can't I continue?
No.
Yeah? That's du, yeah? That's a du. Getting serious on the maths, is it? Like?
Yeah. How do you get 4u squared plus 4?
Yeah, because here's x plus 2.
Uh-huh.
And you can see that x plus 2 equals 2u.
Uh-huh.
So what's x plus 2 squared?
Okay.
If I square this, I square this, and I get this.
Well, why do you do divided by 2? How do we know that in the exam?
Andrew, how did I get the u here?
No, I mean, why do you let u equal x plus 2?
That's what I taught you, man. I understood you the first time. Okay, Andrew, tell him.
You have to use square root the first over the second square.
Okay. 就是画完才，可是还有把它才。
Can I tell you about what again? Okay. Okay. So if you integrate 1 over x squared plus 1 dx, that is tan inverse x. We did this on page...
First semester.
No, not first semester. Come on.
Isn't it like x squared minus n?
Jerry,
Oh, I see.
page 26, question 3 and 4. 26, 3 and 4.
3 and 4. Oh, because you put 0 on the top, they're confusing.
Yes, I suppose so.
Yeah.
Continue. Can I get, please continue, please. Continue.
What I want to do that.
I don't know. No, what I want to do next is I want to try and integrate that thing that you said I couldn't integrate. Because you challenged me. Guys, can we continue now?
This is fun.
Semester 1 workers, they have all of the information. I mean, 2 days.
Teacher, are you sure you will ask all of them?
What?
Like, small as lower a plus b equal lower a smaller a plus b.
Yeah, we did that. I promised you.
What
Oh.
do you ask?
The formula book is on Moodle. You can see it yourself.
That means you won't be that will do me.
I can only give you the formulas that they give me. I don't make the formula book. So if you want, I can print the formula book for me.
Yeah, we would like to have one.
Yeah, okay. Yeah, but I can give you one then. I'll print it out. Do you have class? No, you don't have class after this because...
We have tomorrow.
No, but what I'm saying is if you really wanted today, you could follow me back to the office and I can print it out for you. I have it in an email from Manchester. They emailed it to me. Or if you want, I can just no, I can't. I was going to say I could text it to you, but I can't text this. I can print it for you if you want it. If you want, you can just wait till tomorrow.
It's in Moodle. I mean,
It's on Moodle though.
I mean, it's a formula book or it's gonna.
There
there
might be tiny differences for the latest version, but it's basically going to be the same. It's on Moodle. Okay, so here's a new problem. In the last question, I was worried for a moment that I would have to integrate this because I actually don't know how to integrate it. Let's try and see if we can integrate it. So this was my idea. I have a couple of ideas. I could try to make u equal to x squared plus 4x plus 8, but that might fail. I could complete the square here and write x plus 2 squared plus 2. And then I could say u equals x plus 2 over root 2. Could try that. Now let's just think about what will happen. If I do this, I'll have a u squared plus 1 at the bottom, but I'll still have an x on the top.
Isn't it plus 4?
Or whatever it is, a u squared plus something on the bottom. But I'll still have an x on the top.
Use the f g minus u x.
And yeah, I could possibly use the by parts as well.
To take the x out.
Yeah, I could try that as well. So, why, do you feel that will work? Or are you just giving me an idea? Oh, okay. That's confident speak from Andrew. No, let's try it, Andrew. So, Andrew's idea is to use by parts. So, this we change into x times 1 over x squared plus 4x plus 8 dx. And remember, this is f and this is g derivative. So this will equal f g, which is the integration of this, which is possible to do, minus f derivative, oh sorry, that's an x, sorry, fg minus f derivative
That's g.
f derivative g. Did I do that right? Something feels wrong. F
Yeah.
g, which is the integration of this, minus integrate f derivative g.
Yeah. F is outside. But
G.
Oh, it's actually two integrations here. Because the formula is fg minus integrate f derivative g. And this g is from integrating this. And the second integration is from the formula. Now, although that looks ugly, I can see the answer appearing in the horizon. I can see it. Because here, I can change this into x, integrate 1 over x plus 2 squared plus 4. And here I can do the same thing. And in both cases, I should make u equal to x plus 2 over 2. That's right, isn't it? Yeah. So du dx. No, is someone wrong? That should have been 4 there, actually. Du dx equals 1 over 2. What does x plus 2 equal? 2. And what does du equal? Oh, sorry, I mean to say, what does dx equal? 2 du. So this problem now becomes x integrate 1 over 4u squared plus 4 2 du minus integrate 1 over 4u squared plus 4 2 du. Now I can cancel this down and make this x over 2 and take the 2 out, tan inverse u, wonderful, minus, and I can do the same thing, integrate here tan inverse x plus 2 over 2 dx, and I have a 1 over 2 here, because that makes it 2, which I take out. Now, this is x over 2 tan inverse x plus 2 over 2 minus a half, integrate li tan inverse x plus 2 over 2 times 1 dx. So what I'm going to do now is do the by parts again. This is f and this is g derivative. So this equals x over 2 tan inverse x plus 2 over 2 minus a half f g, which would be x tan inverse x plus 2 over 2 minus f derivative. So I need the derivative of this. right?
Yeah.
What's the derivative of tan inverse? We did this one, didn't
1
we?
over 1 plus x squared.
Yeah, but when it's this one, we need to use the chain rule. So that would be, hang in there, hang on, don't give up. Half over a half x squared plus a quarter, right? Yeah, I think that's right. I hope that's right. And then g, which is x dx. A quarter comes out on the top 4 times a half. 2. So I can delete all of these. I can put the 2 back in, and then I can make the u equal to x squared plus 1, and then this becomes log x squared plus 1 plus, and then it has the half from here, then the x over 2 tan inverse x plus 2 over 2, and they're both minuses because the minus is there, and this is an x over 2 tan inverse x plus 2 over 2. Does that one cancel that one? It looks like it. Am I just left with log? Let's see who that is. Who does it? Are we missing anyone? Ah, who are you looking for? Oh, you're looking for Sean. No problem.
Teacher,
Didn't it cancel?
have you
It looks like it cancels, yeah. Huh?
Can you pull out the phone?
I'm just a little bit not 100% sure if I differentiated this correctly. Is that what I have? No. No, I didn't differentiate this correctly, so I just made a little bit of a mistake here. Derivative of that, and then the x on the top. Log x squared plus 4x plus 8. Yeah, so I just made a mistake in this one here. Anyways, my point is, yes, KJ, we can integrate it, but it is extremely hard because we'll need to use by parts
Chain rule.
twice, chain rules once, and substitution 3 times, I think.
And your life.
Yeah. But I like it so much I kind of want to add it to the book now. But I won't. No, Stephen, don't. Bad Stephen. Okay. I won't. Although I really like it. I really do like it. And good idea, by the way. I think it is a little bit too hard. Even though it's a wonderful question.
You can put it in the last question.
Not this year.
It's not for
Next year.
No, let January do suffer.
Bruce can do it.
You have to do that.
You know what, I will. I'll add it in as a question 2 on this page.
For January student, for Bruce.
Oh, but it's not really a proper partial fraction because I don't think I used partial fractions in this one. It's more of a, what lesson would I have gone on to?
Practical program.
Actually, you know what? It's more like a by parts problem because I needed to use by parts in it twice. So I'll make this a question 5 on the by parts. Could I just have a piece of paper to write the question down?
For next year student.
It's a wonderful question.
By mistake.
By mistake? Well, you know, that's how things happen in life sometimes. It's sad that I'm quite happy by this, but I am. Of this one? Oh no, this one was only for fun. I don't want you to write it down.
Yeah, I can only for fun. I got checked, but I think.
No, I could have easily have made a small mistake somewhere because as KJ spotted, I made a mistake in the chain rule on the tan inverse. I lost a 4x, wasn't it? No. Don't take, this one was only for fun, not for seriousness.
Yeah, I know.
Yeah.
I just want to try.
This one was for seriousness, because this is an
I just want
example.
to try the derivative of the arc tan.
The which one?
I just want to try the formula for the arc tan.
The derivative? Yeah, that one was a little bit hard. Let's do that one on the side. Tan inverse x plus 2 over 2. What would be the best way to do that? We could do the chain rule, or, do you know what, maybe we'll do implicit. Tan y equals x plus 2 over 2. So what's the derivative of tan y? That's 1 over y, oh no, sorry, tan y is 1 over cos squared y, isn't it? Yeah. And that's equal to a half x. Oh, and of course, dy dx. So dy dx is equal to a half x cos squared y. Now, y is tan inverse. You can draw a little triangle here. If that's y, and that's x plus 2, and that's 2, because it's the opposite over the adjacent, then this side will be square root this squared plus this squared, which will be x squared plus 4x plus 8. Yeah, because I'm adding the two squares together. So that's how I missed the 4x because of the Pythagoras. This is x squared, this is a half x, and cos is this over this. So cos squared will be 4 over x squared plus 4x plus 8. So the final answer is 2x over x squared plus 4x plus 8. And then what I did, Chrissy, was I still had to integrate it. So what would be the best way to integrate this, guys? Well, this one is nicely u equals x squared plus 4x plus 8. I think that would work here, or would it? Oh yeah, it wouldn't work.
I just wanted the derivative of the arc tan.
Wait, stop! This here, where does it look familiar? It's the question. Integrating this is the question, so you can do that trick where you bring it over to the left. This question is getting better and better. Yeah, but on the original one it was x over, so you bring it over and you're left with a minus x over, and then just flip the signs. It's the question that doesn't stop giving. Okay, best question this semester so far. Wonderful question.
Well, not for the exam.
Not for the exam, but extremely interesting question, because it has everything in it. Everything. Wonderful. Okay, I think that would be a good point to take a small break and get a cup of coffee, yeah?
Thank you.
I got this.